So today I want to recap how to round off whole numbers and decimals. So let's start out by reminding ourselves of how we used to do these things. So let's say I want to round off 74 to the nearest 10. So this is 74. I want to round it off to the nearest 10. So how can I do that? Well, let's think about it for a second. Here's a number line. And since I want to round to the nearest 10, so this is to the nearest 10, which means that I need to count. I want to skip count in tens. So I'll have 50, 60, 70, and 80, and 90. Okay, so this is skip counting by 10. So this is 5 tens, 6 tens, 7 tens, 8 tens, and 9 tens. Here I have right smack in the middle, I have 75. And please note that 74 is right before 75. Right over here is 74. So now I have to look at the distance to the nearest 10. So you can see that one distance is 4 units. So this distance is 4 units. 74 to 70, the difference is 4. And so this distance is 4. And from 74 to 80, so that's the next 10 because we're rounding to the nearest 10. This distance is 6 because 80 minus 74 is 6, which means that if I want to figure out which 10 is the closest, the answer is 70. So when I want to round off 74 to the nearest 10, so if I try to round off 74 to the nearest 10, I'll say this 74 is equal to 70, and I'll say to the nearest 10. Okay? So now please note, if I have a number like 75, so let's think about 75. If I have a number like 75, so here's 75. So if I think of 75, 75 would be smack in the middle. As you can see, this 75 is exactly halfway between 70 and 80. And so the convention, so this is what I'm going to again tell you, this is a convention that the distance is the same, 75. So here's the number line. This is 75, this is 70, and this is 80. And these distances are, both these distances are 5 units, right? So the convention is that when you approximate something which is smack in the middle, you round up to the nearest 10. And again, this would be to the nearest 10. 75 rounded to the nearest 10 would be 80 and not 70. There's no deep reason for it. It's just a convention. Conventions are rules that people make up so that everybody agrees on the answer. So that's all that there is to it. Okay, so let's try another one. Let's try a problem. So now let's look at a problem like maybe 273.1. Okay, so when we have something like 273.1, so this is the problem that we are trying to do. Let's round it to the nearest 10. Now if you want to round it to the nearest 10, so again we can have a skip counting by 10. So we'll have 260, we'll have 270, we'll have 280, and now note 275 is smack right over here. This is 275, and 273.1 is somewhere over here. It's to the left of, this is where 273.1 is, so it's closer to 270. So the answer is going to be 270. When you round it to the nearest 10, the answer is going to turn out to be 270. Okay, now we can also round 273.1 to the nearest 100. So let's try to round it off to the nearest 100. Now that's a different problem. So now if you want to round it to the nearest 100, we have to skip count by 100. So if I skip count by 100, I'm going to get 100. I'll have 200. I'll have 300. Smack in the middle we have 250. This is in the middle of 200 and 300. 270 is going to be 273.1, to be more precise, is going to be somewhere over here. This is 273.1. So you can clearly see it's closer to 300 as compared to 200. So then the answer will turn out to be 300. Okay. So this is how you approximate it, and as a fun exercise, you can try to see how would you round it to the nearest 1000. If you want to round it to the nearest 1000, just as a hint, I'm just going to put this as a hint. So if you skip count by 1000, this is 0,000s, this is 1000s, and this is 1000. So you're going to have 500 smack in the middle of here. So this is 500. So now you can see where 273.1 is, and you can round it to the nearest 1000, and you can get your answer out. Okay. So what we have actually done is, if I try to recap what we have done, if you want to round it to the nearest 10, what we have really done is we were rounding to the nearest 10. So we focused on the unit, which was 3. So it's 1 to the right. We looked at the number which was 1 to the right because that was a units place, and the units place was less than 5, so then we rounded it down. So now let's think about rounding to the nearest 100. So now if you're rounding to the nearest 100, we are trying to round 273.1 to the nearest 100. So what we have to do is that we have to look at the tens place. In the tens place, we have a 7, and the 7 is greater than or equal to 5. Okay, remember I have to check whether it is equal to 5, and the equal to 5 happens because of the convention, this convention right over here that we have, which is that if your number is smack in the middle of the two skip counts, then you have to round up. So now, since we have a 7 which is greater than or equal to 5, this 7 is going to cause the 273 to get converted into a 300. The 200, because I can only give you an answer which is 200 or 300, the answer turns out to be 300 because we have a 7. So the rule that we have figured out is that we are rounding to the nearest 10, look at the units place. If the units place is less than 5, you round down. If it is greater than or equal to 5, you round up. Similarly, for hundreds, you look at the tens place, and in the tens place, if you find a number which is less than or 5, then you're going to round down. If you get a number which is greater than or equal to 5, you round up. Now, the same sort of principle would apply when you're rounding to decimal places. So let's look at a number like maybe 96.482. So now we are trying to round it off to one decimal place. Now if I want to round off 96.482 to one decimal place, again I am going to start skip counting. So let's make a number line first. So I want to round it to one decimal place. Okay. So now remember so let me first show you. So here's 96.3. I'm going to skip count by tens. This is going to be 96.4. This is going to be 96.5. Our number is 96.482. So remember, this is 96.45. So I'm going to put in a 96.45 here. And our number, the number that we are interested in, 96.482. And it's really the 8 that determines that we go right over here to the right. So this is 96.482, and since it's to the right, when we try to approximate it, the answer is going to turn out to be 96.5 to one decimal place. This is to one decimal place. Okay. Now let's try again, and let's try to two decimal places. Okay, so if we have the same number, which is 96.482, now remember, first let's follow the algorithm, and then we'll see it once we draw it. So since we want to round off to 2 decimal places, we have to look at the third digit, the hundredths, sorry, the thousandths place. We have to round off to the hundredths place, we have to look at the thousandths place. If you look at the thousandths place, 2 is less than 5. So this means the answer ought to be equal to 96.48, and this is to 2 decimal places. Let's just make sure we understand 2 decimal places. Okay, so why is that? Let's just see. So now I'm going to skip count. So this is 9 by hundredths, 96.48. This is going to be 96.49. I have something smack in the middle, which is 96.485. 96.485. And now note, this is a 5, whereas this is a 2. So that means 96.482 is going to be to the left of 96.485. So the our number is going to be right over here, which is going to be 96.482 in this region. So since it is to the left of 96.485, I'm going to round down, and the answer is going to be 96.48. So hopefully this idea of rounding is clear. You always look at the decimal or any place to the right. So in place value, what you do is you look at, if you want to round to any digit, you look at the digit to the right. If the digit to the right is less than 5, you round down. If it is greater than or equal to 5, you round up. The equal to 5 is a convention, but that's a convention that everybody follows. So this is the summary of what we have learned today.